So how are you feeling? Are you excited?
Very excited. Very excited to go out and burn in the sun.
So I'm really excited today because that's the day where we are attaching the infrared camera that we've developed here at OroraTech. We are attaching it to a drone and then it will be flown into the air up to 3,500 feet. Yeah, we are actually filming fires from up there in the air, and that will be simulated the later satellite flight that we will have, and it's a really important test for us, as we will then see the real performance that we will have then later on in space simulated on a drone flight. So we hope to detect the fires that we are generating on ground, and that we actually test our full platform on functionality and also performance, what we will then expect then to see in space later on. So I'm really excited to see actually going this thing up into the air. That's like really awesome, because we have built it so long for now, so a lot of months, and now it's finally getting up into the air. And then I'm really excited to see the data that is coming out, so the images. So now we have real images that we can work on, where we can analyze our algorithms that we have programmed for fire detection. And that's now finally the day where we can actually accumulate this data.
So as you can see, there is a grill with firewood, which is a live flame, and then there is a black body source, which is a calibrated instrument for emitting the ideal heat. And then there is a gas stove with a sample of a sand in an aluminum container. So the sand is heated to about 100 degrees Celsius, which is sort of what is left after a fire is burned. So it's a scorched earth, let's say. Imager, we intend to do a couple of things. One thing we want to detect is the soil temperature, which is the temperature of regular soil, which is around, say, 30 degrees Celsius or 35 degrees Celsius on a hot day like this. We are also measuring the temperatures of all the heat sources, the fire and the black body and the sand. So we intend to estimate the temperature of fires, for example, with a reasonable accuracy. Let's say if the fire is running at 500 degrees Celsius, we want to estimate the size of the fire and the temperature of the fire. So in a pixel, let's say only 10% of the pixel is burning, so we want to estimate from the radiometric intensity what is the size of the fire. And let's say if it's 600 degrees Celsius, then we want to estimate within plus minus 100 degrees Celsius of that as a fire. Whereas for the soil temperature, where it's 35, we want to do something known as land surface temperature measurement. So we want to estimate the surface temperature with a reasonable accuracy of plus minus 3 degrees Celsius.
So, wenn's geht. Ja.
Okay.
Stay behind the cars, so maybe behind Nico's car or here. Anfang August. Also, ja. Das muss gemacht werden.
Like this? Thanks.
Die Sache gleich von vorne raus. Wir sind Zeiten.
So we just did a test flight with the drone integrated with our payload, which is a thermal camera and a visible camera, which is designed for a balloon flight and eventually on our 3-unit CubeSat. So we just did a small test flight where we flew over some fires that you see behind us, which are heat sources, which is what we are looking for with our thermal cameras. The drone flew over our heat sources, and we are now, Rupert here is checking if we recorded any data. So this was just a short hop to see everything works. In the next flight, we are going to do a couple of passes where the drone flies over the heat sources a couple of times at different altitudes, and we get different sizes of the fires. So this is what would happen once our satellite is up there. It will record fires which are a lot smaller than 200-meter resolution, which is the resolution of the thermal camera. So at the end, we would we aim to record fires that are 100 square meters or smaller in a 200 meter by 200 meter pixel. So we are reading thermal and visible camera data. So the thermal camera records data at 25 frames per second, and we are reading that right now to see if it saw any of the heat sources. By the looks of it, it looks like it did.
We had today a really awesome drone flight with our payload that we have built. So that was perfect weather, perfect conditions for us. We had a small fire that we just tested our camera with, and we had different altitudes with a drone flying here over the fields. As you can see, it's still a bit cloudy, so we're really interested also in the data that we've captured where we were actually above the clouds with the drone, so that is also something where we are really interested in. So we had a lot of different situations here simulated with the drone flight, and yeah, we're really happy now that we have all the data now recorded, and we're really looking forward now onto the data evaluation and having a look how good we saw the fires and how the imager performed.